When Marcus Sullivan joined the crew of the Poseidon Majesty, the world's most advanced luxury cruise liner, he was assigned to the maintenance department, despite his 30 years as a nuclear submarine engineer. Keep the toilets flowing and stay out of sight, the ship's arrogant chief engineer instructed, dismissing Sullivan's decorated naval career as irrelevant to real maritime operations. 3 days into the Mediterranean voyage, the Poseidon Majesty collided with a partially submerged shipping container, tearing a catastrophic gash below the waterline that disabled the ship's main engines and emergency power systems. As freezing seawater flooded the lower decks and the state-of-the-art vessel began listing dangerously, panic spread among the 3,000 passengers. The captain's desperate mayday revealed the horrifying truth: in rough seas with no power, the massive ship would sink within 5 hours, and the nearest rescue vessels couldn't arrive for 7. What happened next would force the entire cruise industry to redesign their emergency protocols, as the mere maintenance man executed an engineering feat naval architects had deemed theoretically impossible. Poseidon Majesty cruise ship, Mediterranean Sea, present-day Sullivan. We've got complaints about slow drainage in the platinum deck staterooms. Handle it before dinner service, Chief Engineer Raymond Whitmore instructed without looking up from his tablet. Yes, sir, Marcus Sullivan replied, with the reflexive discipline of his 30 years in the Navy. At 62, he stood ramrod straight, despite the indignity of his assignment, his weathered hands accepting the work order with the same precision he had once used to maintain nuclear reactor systems on Virginia-class submarines. Whitmore finally glanced up, irritation flashing across his features. And remember, stay out of sight. Platinum deck guests paid $60,000 for this cruise. They don't want to see maintenance staff. Understood, sir, Sullivan responded evenly, tucking the work order into his pocket. As he turned to leave the gleaming engineering control center, Sullivan overheard Whitmore addressing his assistant. Remind me why we hired a submarine engineer for basic maintenance. The assistant's reply was equally dismissive. Corporate diversity initiative, military veteran employment program, great for PR, apparently. Sullivan pretended not to hear as he exited into the service corridor. After 3 weeks aboard the Poseidon Majesty, he had grown accustomed to such comments. The cruise line had prominently featured his military service in their promotional materials. 30-year naval engineering veteran joins Poseidon luxury fleet, while relegating him to unclogging toilets and fixing jammed cabin doors. The irony wasn't lost on him. The Poseidon Majesty was marketed as the most technologically advanced cruise ship ever built, a floating city powered by state-of-the-art hybrid engines, with redundant safety systems and automation that supposedly made it unsinkable, though marketing had wisely avoided using that precise term. Yet the ship's engineering department, led by Whitmore and his team of young commercially trained engineers, viewed military experience as irrelevant to civilian maritime operations. As Sullivan made his way through the labyrinthine service passages toward the platinum deck, he mentally reviewed the ship's schematics. Despite his lowly position, he had spent his off hours studying the Poseidon's design, noting with professional interest both its innovations and its potential vulnerabilities. Some of the latter concerned him, particularly the proximity of the main power distribution systems to the secondary hull, a design choice that prioritized space efficiency over redundancy. When he reached the platinum deck, Sullivan was immediately reminded of the vast divide between the ship's passengers and crew. While he navigated narrow service corridors, the guests enjoyed palatial accommodations with panoramic ocean views, private balconies, and luxury amenities. The stateroom with the reported drainage issue belonged to a Silicon Valley executive traveling with his family. Finally, the executive remarked when Sullivan arrived, "We reported this problem hours ago." Sullivan nodded respectfully. "I'll have it resolved quickly, sir." Working efficiently, Sullivan identified and cleared the blockage in less than 15 minutes. As he was completing the repair, he noticed the executive's young daughter watching him with curious eyes. "Are you a sailor?" she asked, pointing to the submarine service pin he kept affixed to his maintenance uniform, a small act of pride he maintained despite his current role. Sullivan smiled. I was, yes, submarine engineer for 30 years. Like Hunt for Red October, the girl asked excitedly. Something like that, Sullivan chuckled, though with fewer dramatic chases. The executive overheard the exchange and seemed to reassess Sullivan with newfound interest. Nuclear submarines, that's quite a career change. Working maintenance on a cruise ship. Just continuing to serve in a different capacity, sir, Sullivan replied diplomatically, omitting the months of rejection letters from defense contractors who considered him too senior. Corporate code for too old and too expensive. As Sullivan gathered his tools to leave, the ship's public address system chimed with an announcement. Ladies and gentlemen, this is Captain Harrington. We're expecting some mild turbulence this evening as we navigate through a storm system. Please secure any loose items in your staterooms and use caution when moving about the ship. But the announcement didn't mention what Sullivan had noted during his daily review of the ship's navigation charts, was that the storm had forced the Poseidon Majesty to deviate from its planned course, taking them through a shipping lane known for occasionally losing cargo in rough seas. Later that evening, as Sullivan completed his shift log in the cramped maintenance office, he felt a subtle change in the ship's motion. The nearly imperceptible rhythm of the engines that experienced maritime engineers could sense through the deck plates. The Poseidon was adjusting course again, likely navigating around something in their path. His 30 years of submarine experience had attuned him to the language of a vessel, the vibrations, sounds, and subtle motions that communicated its condition. Something about this particular adjustment raised his professional concern. He was about to call the engineering control center when a violent impact shuddered through the entire ship. The collision alarm immediately blared throughout the vessel, followed by Captain Harrington's voice, now stripped of its earlier reassuring tone. All crew to emergency stations. This is not a drill. Repeat, all crew to emergency stations. In the chaos that followed, no one would notice the maintenance engineer moving purposefully against the flow of panicking crew members, heading not to his assigned emergency station, but toward the point of impact. Marcus Sullivan's decades of naval crisis management had just activated, and he was already calculating scenarios that the cruise ship's leadership hadn't begun to contemplate. The impact had struck with enough force to throw passengers from their beds and send unsecured items crashing throughout the ship. As Marcus Sullivan made his way down to the lower decks, he passed scenes of increasing chaos. Crew members attempting to calm frightened passengers, officers rushing to emergency stations, and the distinctive sound of alarms indicating multiple system failures. When he reached Deck 2, the severity of the situation became immediately apparent. Seawater was already ankle-deep in the corridor, flowing from the direction of the forward cargo hold. The emergency bulkheads, designed to contain flooding, were attempting to close, but appeared to be malfunctioning, likely due to damage from the initial impact or power fluctuations. Sullivan waded through the rising water, moving against the flow of evacuating crew members. A junior engineer recognized him and called out in confusion, "Sullivan, what are you doing?" "Engineering command is gathering on Deck 7. Someone needs to assess the breach directly," Sullivan replied without slowing. "Tell Chief Whitmore I'm checking the forward compartments." The young engineer looked uncertain, but continued toward the evacuation point. Sullivan pressed forward, reaching the partially closed bulkhead that led to the cargo area. Forcing his way through the narrow opening, he found himself in a rapidly deteriorating situation. The ship had apparently collided with a partially submerged shipping container, a known hazard in heavy shipping lanes during storms. The massive metal container had torn a jagged gash along the Poseidon's hull, breaching both the outer and inner hulls. Worse, the point of impact had damaged the main electrical conduits that powered the ship's engines and critical systems. As Sullivan conducted his rapid assessment, he heard splashing behind him. Chief Engineer Whitmore and 2 senior engineers had arrived, their expressions shifting from anger at Sullivan's unauthorized presence to shock at the extent of the damage. "My God," Whitmore breathed, taking in the catastrophic scene. "Impact breached both hulls," Sullivan reported concisely, falling into his naval damage assessment protocol. "Primary electrical conduits severed, bulkhead closure compromised. We're taking on water faster than the pumps can handle, assuming the pumps maintain power, which is unlikely given the electrical damage." Whitmore stared at him, momentarily forgetting their hierarchical differences in the face of crisis. "How long?" "At current flooding rate, critical buoyancy compromise in under 5 hours, Sullivan estimated. But the immediate concern is power. When those distribution panels submerge, we'll lose all remaining systems." As if emphasizing his point, the emergency lights flickered ominously. "We need to evacuate," one of the senior engineers insisted. "Get everyone to the lifeboats." Whitmore's communication device crackled with the captain's voice. "Engineering, report status immediately." "Multiple hull breaches, Captain," Whitmore responded, his voice tight with stress. "Critical damage to power distribution systems. Recommend immediate passenger evacuation protocols." "Understood," Captain Harrington replied grimly. "However, Coast Guard reports nearest vessels are 7 hours away at minimum. Storm conditions making helicopter evacuation impossible. We need solutions to keep this ship afloat longer." Sullivan was already moving deeper into the damaged area, examining the critical junction where the power distribution systems connected to the ship's backup generators. His mind raced through potential scenarios, drawing on decades of experience with damaged vessels in far more hostile environments than the Mediterranean. "Sullivan, get back here," Whitmore shouted. "This area is unstable." Sullivan ignored the command, his focus entirely on the engineering problem before him. The ship's design had a critical flaw he'd noticed during his study of the schematics. The main and backup power systems shared a vulnerable connection point. With rising water threatening this junction, the entire ship would soon be without power, accelerating the disaster timeline catastrophically. "We need to reroute the backup power system," Sullivan called back, already formulating a plan. "If we can bypass the damaged distribution panels and create an independent circuit to the emergency systems, we can maintain essential functions." Whitmore waded toward him, frustration warring with desperation. "That's impossible. The backup systems aren't designed to operate independently from the main distribution network." "On a conventional vessel, yes," Sullivan agreed. "But the Poseidon has the new quantum parallel processing modules for its navigation systems. They can be repurposed as power regulation nodes." The chief engineer stared at him in confusion. "Those are navigation computers, not power management systems." "That's not possible. It's not conventional," Sullivan corrected. "But it's possible. I implemented a similar solution during a reactor crisis on the USS Virginia, when standard protocols failed." For a moment Whitmore seemed ready to dismiss Sullivan's suggestion outright, the reflexive rejection of ideas from someone he had categorized as merely maintenance staff. But the dire circumstances and Sullivan's confident expertise gave him pause. "What do you need?" he finally asked. "Access to the ship's electrical engineering supplies, 2 assistants who can follow precise instructions, and communication with the bridge," Sullivan replied immediately. "And we need to move quickly. When those panels submerge, our options disappear." As the water continued to rise around them, Whitmore made his decision. "Johnson, Richards, you're with Sullivan. Whatever he needs, make it happen." He turned back to Sullivan, with a humbled expression. "Save my ship, Sullivan." Sullivan nodded once, already mentally mapping the complex procedure ahead. "Have the captain reduce power consumption to absolute minimum. Every non-essential system needs to be shut down immediately." As Whitmore relayed these instructions to the bridge, Sullivan led his newly assigned team toward the engineering storage areas. The Poseidon Majesty's fate now rested in the hands of the man they had dismissed as just a maintenance worker, a man whose decades of experience with damaged vessels in the world's most challenging environments was suddenly the passenger's only hope for survival. The auxiliary control room on Deck 3 had already begun flooding when Sullivan and his team arrived. They had less than 30 minutes before the water would reach critical electrical systems. Working with the focused intensity that had defined his submarine career, Sullivan quickly organized their emergency operation. "Johnson, strip those navigation processor modules," he directed, pointing to a bank of sophisticated computers. "Richards, I need the high-capacity data transfer cables from communications, all of them." As the younger engineers rushed to comply, Sullivan accessed the ship's electrical schematics on an emergency terminal. The conventional approach, following standard maritime emergency protocols, would be futile, given the damage pattern. Instead, he was mentally designing a solution that drew on his unique experience with damaged nuclear submarines, where improvisation within rigorous engineering parameters had sometimes been the only option. "Sullivan," Whitmore's voice came through the communication system. "Captain reports forward bulkhead in sections C through E are showing signs of structural failure. Estimated time to complete collapse is 40 minutes. "Understood," Sullivan replied without looking up from his work. "Tell him we'll have emergency power rerouted before then. Have all passengers moved to upper decks, aft sections." The chief engineer hesitated. "The procedure you're attempting isn't in any emergency protocol I've studied, because it's never been done on a civilian vessel," Sullivan confirmed, now disconnecting critical power couplings with precise movements. "This is adapted from a classified naval engineering emergency procedure developed for nuclear submarines." Richards returned with an armful of cables, his expression betraying his doubt. "Sir, these are fiber optic data lines. They can't carry the power load needed for ship systems, not individually." "No," Sullivan agreed, taking the cables, "but the Poseidon's quantum navigation system uses multi-channel data architecture with power amplification at each node. If we bundle these correctly and repurpose the amplifiers, we can create a sufficient power pathway." Johnson looked up from the navigation processes he was dismantling. "That's theoretically possible, but the power regulation would be impossible to calibrate manually." Sullivan allowed himself a small smile. "In standard conditions, yes, but we're not trying to maintain optimal operation. We just need enough stability to keep essential systems running until rescue arrives." As Sullivan continued outlining his unprecedented approach, the younger engineer's expressions shifted from skepticism to growing amazement. What had initially seemed like a desperate, perhaps delusional plan, was revealing itself as a brilliantly innovative solution based on deep engineering knowledge. "The navigation quantum processors have independent power regulation systems," Sullivan explained as he worked, "designed to maintain precise operation during power fluctuations. We're going to repurpose them as power management nodes for the entire emergency system." The complexity of the procedure would have been daunting for even experienced maritime engineers, but Sullivan directed the operation with the calm authority of someone who had faced far worse crises. His hands moved with practiced precision, despite the rising water now reaching their knees, connecting components in configurations their designers had never intended. Captain Harrington's voice came through the communication system, tension evident despite his professional tone. "Engineering, we've established contact with rescue vessels. Nearest assistance, still approximately 6 hours out. Multiple compartments now flooding. How much longer for emergency power rerouting?" Whitmore looked to Sullivan, who was making final adjustments to the improvised power system. 20 minutes, Captain," Sullivan responded directly. "Recommend powering down all remaining non-essential systems now to reduce load during transition." "The passengers are frightened, Sullivan," the captain replied. "Losing lighting and climate control ship-wide could trigger panic." "Better frightened than drowned, sir," Sullivan responded with the blunt pragmatism of a military engineer. "We need to reduce power draw to absolute minimum if this bypass is going to sustain critical systems." After a brief pause, the captain conceded, "Implementing ship-wide power reduction now. Godspeed, engineering." As the ship's lighting dimmed to emergency levels, Sullivan directed the final phase of their improvised solution. The water had now risen to mid-thigh level, threatening the very systems they were working to save. "On my mark, we'll initiate the bypass," Sullivan instructed his team. "Whitmore, have damage control teams standing by. When we switch over, we'll likely see power surges throughout remaining systems." The chief engineer nodded, his earlier arrogance completely abandoned in the face of Sullivan's evident expertise. "Teams are ready. All passengers have been moved to upper decks with life jackets." Sullivan completed the final connections, checking each critical junction with the methodical precision that had once been applied to nuclear reactor systems. Initiating bypass in 3, 2, 1, now. For a terrifying moment, as Johnson activated the improvised system, all remaining lights went dark throughout the ship. In the pitch blackness, the only sound was the continuing rush of water into the damaged vessel. Then, one by one, essential systems began to reactivate: emergency lighting, communication systems, and most critically, the pumps fighting to remove water from the ship's lower compartments. The bypass was working, channeling power through pathways never envisioned by the ship's designers. "Power stabilizing," Richards reported with undisguised awe, checking the readouts. "Emergency systems at 63% capacity and holding." "It worked," Whitmore breathed, the admission almost involuntary. Sullivan was already moving to the next phase. "This buys us time, but we're still taking on water faster than the pumps can remove it. We need to reduce the inflow rate." Without waiting for authorization, Sullivan outlined his plan for creating an improvised cofferdam around the major breach points, another technique adapted from submarine emergency protocols, but never applied to a cruise ship. As he spoke, the younger engineers listened with rapt attention, witnessing a masterclass in crisis engineering from a man they had previously seen only unclogging toilets. Captain Harrington's voice returned over the communication system, relief evident. "Engineering, bridge. We're showing emergency systems stabilizing ship-wide. Structural integrity teams reporting reduced stress on compromised bulkheads. Whatever you did down there just bought us precious time." Whitmore looked at Sullivan with newfound respect. "Captain, all credit goes to Sullivan. He implemented an emergency bypass procedure I've never seen before." "Mr. Sullivan," the captain acknowledged, "the 3,000 souls aboard this vessel owe you their gratitude. Please continue advising our engineering team until rescue arrives." As Sullivan led the effort to implement his cofferdam solution, he found the ship's engineering staff now treating him with the deference typically reserved for their chief. The transformation was as sudden as it was complete, from invisible maintenance worker to the recognized expert, whose unique knowledge represented their best hope for survival. Dawn broke over the Mediterranean, with the Poseidon Majesty still afloat, listing significantly to starboard, but maintaining sufficient buoyancy to keep its upper decks well above water. Sullivan's innovative emergency measures had extended the ship's survival time from the initial estimate of 5 hours to nearly 11, providing crucial additional time for rescue operations. On the port side of Deck 8, Sullivan coordinated with approaching rescue vessels, his maintenance uniform now supplemented with an officer's jacket hastily provided by Captain Harrington. The transformation in how he was perceived by the ship's leadership was complete, from dismissed maintenance worker to the acknowledged expert directing their survival efforts. "Coast Guard command vessel approaching from southeast," Sullivan reported, studying the Maritime tablet he'd been given. "Their draft is too deep to approach our starboard side, given our list angle. Recommend redirecting them to port side, midship section." Captain Harrington nodded, no longer questioning Sullivan's assessments. "Relay that to Coast Guard Command. Sullivan's directions are to be followed precisely." The rescue operation was proceeding with remarkable efficiency, given the circumstances. Sullivan had reorganized the ship's evacuation protocols, implementing a systematic approach that prioritized smooth passenger transfer while maintaining the damaged vessel's precarious stability. "The improvised power bypass is still holding," Chief Engineer Whitmore reported, approaching Sullivan with the deference now accorded to him. "Structural integrity teams report bulkhead pressure within sustainable limits. Your cofferdam solution reduced water ingress by nearly 70%. Sullivan acknowledged this with a professional nod. The ship will hold long enough to complete evacuation, but the power bypass will eventually fail as water continues rising. We need to maintain current evacuation pace." As they spoke, a Coast Guard helicopter hovered overhead, its downdraft creating ripples across the calm morning sea. From its side door, Maritime officials observed the damaged cruise ship with evident amazement. The vessel should have sunk hours ago, according to standard maritime engineering assessments. The first rescue vessel, a large Coast Guard cutter, had now positioned itself alongside the Poseidon's port side, extending transfer bridges to begin taking on passengers. Sullivan supervised this critical operation personally, ensuring the weight distribution didn't compromise the ship's tenuous stability. "Mr. Sullivan," called a Maritime Authority official who had boarded from the rescue vessel, "I'm Commander Ramirez, Maritime Disaster Response. Our engineers are astounded by the emergency measures you implemented. They're saying it shouldn't have been possible to maintain power with that damaged configuration." Sullivan continued monitoring the passenger transfer while responding. "Conventional approaches wouldn't have worked. The solution required adapting techniques developed for nuclear submarine emergencies." "You have submarine experience?" Ramirez asked. 30 years, engineering officer on Virginia-class submarines," Sullivan replied matter-of-factly. The commander's expression registered surprise followed by confusion. "May I ask why someone with your qualifications was working in cruise ship maintenance?" Before Sullivan could respond, Captain Harrington joined them. "A question many of us will be asking ourselves in the coming days, Commander. Suffice to say, we failed to recognize the expertise we had aboard." As the morning progressed, the evacuation continued with methodical efficiency. Sullivan had organized the engineering crew into specialized teams, each focused on specific aspects of maintaining the vessel's integrity during the passenger transfer. The younger engineers, who had initially viewed him with indifference or confusion, now followed his instructions with dedicated precision, many taking notes on techniques they'd never encountered in their conventional maritime training. By mid-afternoon, over 2,800 passengers had been safely transferred to rescue vessels. The remaining passengers and non-essential crew were being evacuated, according to Sullivan's carefully calculated schedule. Throughout the operation, maritime authorities and shipping officials had arrived to observe the unprecedented success of keeping a catastrophically damaged cruise ship afloat long enough for complete passenger evacuation. Sullivan, Chief Engineer Whitmore approached, his demeanor markedly different from their first interactions. "The Maritime Safety Board wants to document your emergency bypass system before we abandon ship. They're saying it represents a significant advance in maritime disaster response." Sullivan nodded. "I'll provide complete documentation. They should incorporate elements into standard emergency protocols, particularly for vessels with quantum navigation systems." Whitmore hesitated, then extended his hand. "I owe you an apology, Sullivan. I made assumptions based on your assignment rather than your qualifications. Those assumptions nearly cost lives." Sullivan accepted the handshake with professional grace. Hierarchies have their place in normal operations. Emergencies sometimes require different perspectives. As the final passengers were evacuated, and only essential crew remained aboard, Sullivan conducted a thorough assessment of the ship's condition. Despite his innovative measures, the Poseidon Majesty would not survive much longer. The damaged hull continued taking on water, and the improvised power systems would eventually fail. Captain Harrington gathered the remaining officers on the bridge for a final consultation before abandoning ship. The once gleaming command center now operated on minimal emergency power, with manual systems replacing the sophisticated automation that had been the vessel's hallmark. "Gentlemen," the captain addressed them solemnly, "thanks to Mr. Sullivan's extraordinary efforts, all passengers and most crew have been safely evacuated, an outcome that maritime authorities are calling miraculous given the extent of damage we sustained. We've done everything possible to save this ship, but the time has come to leave her." Sullivan, now treated as a senior officer despite his maintenance uniform, provided his final assessment. "Structural integrity is compromised beyond recovery. The power bypass will fail within approximately 3 hours as flooding reaches the auxiliary control room. Recommend complete evacuation within the next 90 minutes. The captain nodded gravely. "So noted, Mr. Sullivan. I would consider it an honor if you would coordinate our final departure." This ultimate acknowledgement, entrusting the ship's final moments to the man they had once dismissed, was not lost on anyone present. Sullivan accepted with the same quiet professionalism that had characterized his response throughout the crisis. As the officers dispersed to prepare for final abandonment, a young engineer approached Sullivan hesitantly. "Sir, several of us were wondering, would you consider conducting training sessions on your emergency techniques once we're ashore? What you did here isn't taught in any maritime academy." Sullivan considered the request, a hint of satisfaction crossing his weathered features. "I'd be glad to share what I know." By sunset, the last rescue vessel pulled away from the Poseidon Majesty with the remaining crew aboard. From its deck, Sullivan watched the damaged ship that engineering principles said should have sunk many hours earlier. His improvised solutions had defied conventional maritime disaster timelines, allowing for a complete evacuation without a single life lost. Captain Harrington stood beside him at the railing. "The cruise line's executive team is waiting to speak with you when we reach port. I believe they'll have a significantly different position available than the one you've been filling." Sullivan nodded, his gaze still on the damaged vessel. "I didn't join this crew for advancement, Captain. I joined because being at sea is where I belong." "Nevertheless," the captain replied, "I believe your days of unclogging toilets are behind you." Maritime Safety Board Headquarters, London. 3 months later, the grand auditorium fell silent as Marcus Sullivan approached the podium, the applause that had greeted his introduction slowly fading. Before him sat the most distinguished gathering of maritime engineering experts, safety officials, and industry leaders assembled in recent memory, all drawn by the extraordinary events aboard the Poseidon Majesty. The innovations implemented by Chief Engineer Sullivan during the Poseidon Majesty disaster represent a paradigm shift in emergency response protocols. Admiral Richardson, chairman of the International Maritime Safety Board, had stated in his introduction, his unconventional solutions not only saved 3,000 lives, but have provided the maritime industry with new approaches to catastrophic damage scenarios previously considered unsurvivable. Sullivan, now dressed in the formal uniform of Oceanic Cruise Line's newly created position of Chief Safety Engineer, addressed the audience with the same unassuming professionalism that had characterized his response during the crisis. "Engineering is fundamentally about solving problems with the resources available," he began. "Sometimes those solutions require looking beyond conventional protocols to the underlying principles of the systems we're trying to save." Behind him, large screens displayed technical diagrams of what had become known throughout the maritime industry as the Sullivan method, the innovative emergency power bypass that had kept the critically damaged cruise ship afloat long enough for complete evacuation. Maritime academies worldwide were now incorporating these techniques into their advanced emergency response training. In the front row, Oceanic Cruise Line's CEO and executive team watched with expressions that mixed pride with lingering embarrassment. The company had faced difficult questions about how they had assigned a highly qualified submarine engineer to basic maintenance duties, overlooking expertise that ultimately saved their flagship vessel and all souls aboard. Their response had been comprehensive, creating a new executive-level position for Sullivan, revamping their hiring practices, and implementing what they now prominently advertised as the industry's most rigorous emergency preparation protocols. Chief Engineer Whitmore, seated among the Maritime Academy instructors where he now taught alongside his emergency management duties, nodded appreciatively as Sullivan outlined the technical aspects of his improvisations. The experience had transformed Whitmore as well, humbling him and reshaping his approach to maritime hierarchy and expertise. The critical insight, Sullivan explained to the rapt audience, was recognizing that modern cruise ships contain sophisticated systems designed for one purpose that can be repurposed during emergencies. The quantum navigation processes aboard the Poseidon Majesty were never intended as power management systems, but their architectural design made them adaptable to this critical function when conventional systems failed. As Sullivan continued his presentation, maritime engineers furiously took notes. The implications of his approach extended far beyond cruise ships. Commercial vessels, naval operations, and even offshore platforms could implement variations of his techniques. Captain Harrington, now promoted to Oceanic's Fleet Operations Director, watched from the side of the stage with evident satisfaction. He had been among the first to recognize the significance of Sullivan's contributions, not just to the immediate crisis, but to maritime safety as a whole. After concluding his technical presentation, Sullivan addressed the human element that had been discussed extensively in the maritime press. Much has been made of my position aboard the Poseidon Majesty before the accident. I want to emphasize that hierarchical structures serve important functions in maritime operations. However, this incident reminds us that expertise can reside anywhere within an organization, and emergency situations sometimes require us to look beyond conventional authority structures. This diplomatic characterization of how he had been overlooked and dismissed drew knowing smiles from many in the audience. The maritime industry publications had been less charitable, with headlines like "Cruise Line Relegated Hero Engineer" to "Plunging Toilets and Maintenance Man's Miracle, How Ignored Expertise Saved 3,000 Lives." As the formal presentation concluded, Admiral Richardson returned to the podium with a special announcement. In recognition of Chief Engineer Sullivan's extraordinary contributions to maritime safety, the International Maritime Safety Board unanimously votes to establish the Sullivan Medal for Engineering Innovation in Crisis Conditions. This annual award will recognize maritime engineers who demonstrate exceptional problem-solving abilities under emergency circumstances. The announcement triggered a standing ovation throughout the auditorium. Sullivan accepted the honor with characteristic modesty, appearing almost uncomfortable with the attention now focused on him after decades of working in relative obscurity. Following the ceremony, Sullivan found himself surrounded by maritime officials, industry leaders, and engineering students eager to discuss his techniques in greater detail. Among them was a group of young engineers from various cruise lines who had formed a special study group dedicated to adapting the Sullivan method to different vessel configurations. Mr. Sullivan approached a young woman who introduced herself as a recent graduate of the Maritime Academy. "Your emergency procedures have become the core of our advanced crisis management curriculum. Would you consider giving a guest lecture series next semester?" Before Sullivan could respond, Captain Harrington joined them. "I'm afraid you'll need to get in line, Lieutenant. Mr. Sullivan's schedule is becoming rather crowded these days." Indeed, the transformation in Sullivan's professional standing had been as rapid as it was complete. From the overlooked maintenance worker, he had become one of the most sought-after consultants in maritime engineering, with speaking invitations from naval academies, engineering conferences, and cruise industry safety boards worldwide. Later that evening, at a private reception hosted by Oceanic Cruise Line, the company's CEO approached Sullivan with an envelope. "The board unanimously approved this," he said, handing it to Sullivan. "We can never fully compensate for our failure to recognize your expertise earlier, but we hope this demonstrates our commitment to properly valuing your contributions now." Inside was a contract offering Sullivan a position as Executive Director of Engineering Safety across their entire fleet, with compensation and authority commensurate with his newly acknowledged expertise. More significantly, the contract included funding for a comprehensive training program, allowing Sullivan to share his knowledge with the next generation of maritime engineers. "This is generous," Sullivan acknowledged, reviewing the document. "It's overdue," the CEO corrected, "and frankly, it's in our self-interest. The shipping industry hasn't faced a disaster of this magnitude without loss of life in decades. Your methods have already been implemented across our fleet, and our competitors are scrambling to catch up." Sullivan considered the offer thoughtfully. "I'll accept on one condition. I want to remain operational, spending time on vessels, not just in corporate offices. The practical application is where these techniques matter most." "Done," the CEO agreed without hesitation. "Our passengers would sleep better knowing you're aboard anyway." As the reception continued, Sullivan found a moment of quiet on a balcony overlooking the Thames. Chief Engineer Whitmore joined him there, 2 glasses of scotch in hand. "Quite a change from unclogging toilets on the Platinum deck," Whitmore observed, offering Sullivan a glass. Sullivan accepted with a slight smile. "Every role on a ship has its purpose." "True," Whitmore acknowledged, "but some of us failed to recognize when the man assigned to that role was capable of far more." He raised his glass. "To expertise found in unexpected places." Over the following year, the Sullivan method became standard in maritime emergency training worldwide. Sullivan himself divided his time between hands-on fleet safety inspections, teaching at maritime academies, and continuing to refine emergency protocols for various vessel types. The principles he had implemented during those critical hours aboard the Poseidon Majesty were expanded and formalized into comprehensive emergency response systems. Perhaps most significantly, Sullivan's experience led to a fundamental reassessment of how maritime operations evaluated and utilized expertise. Cruise lines and shipping companies implemented new procedures for identifying specialized knowledge among all crew members, regardless of their assigned positions, acknowledging that in crisis situations, the hierarchy of expertise sometimes differed from the hierarchy of rank. 18 months after the Poseidon Majesty incident, Sullivan found himself aboard Oceanic's newest vessel, the Atlantis Sovereign, as it completed sea trials before its maiden voyage. As chief safety engineer, he had been instrumental in designing its revolutionary emergency systems, many incorporating principles derived from his submarine experience. On the bridge, Captain Harrington, who had specifically requested command of this vessel, welcomed Sullivan with evident respect. "The crew has been briefed on your role, Marcus. I believe you'll find the engineering department particularly eager to work with you." Sullivan nodded appreciatively. "I reviewed their qualifications. Impressive team." "We've learned our lesson about overlooking expertise," Harrington replied, "though I doubt we'll find another submarine engineer hiding in our maintenance department." As they completed the final safety inspection, a junior officer approached with a magazine. "Sir, the latest issue of Maritime Engineering Journal. I thought you might want to see the cover." The magazine featured a comparative analysis of contemporary maritime safety protocols, with the headline, "The Sullivan Revolution: How One Engineer's Crisis Response Reshaped Maritime Safety Standards." The article detailed how Sullivan's improvised solutions during the Poseidon Majesty disaster had evolved into new international standards for emergency response. Sullivan accepted the magazine with his characteristic modesty. The principles were always there, they just needed application in a different context, and someone with the knowledge and courage to implement them when conventional wisdom said it was impossible, Harrington added. As the Atlantis Sovereign prepared for its inaugural voyage, Sullivan conducted a final walkthrough of the engineering sections. The sophisticated systems represented the cutting edge of maritime technology, but now with emergency contingencies that drew directly from his experience. What had once been dismissed as irrelevant military engineering had become the new standard in civilian maritime safety. In the main engineering control center, a plaque had been mounted, bearing a quote Sullivan had offered during his International Maritime Safety Board address. In crisis situations, expertise matters more than rank, innovation more than convention, and adaptability more than adherence to standard protocols. The once overlooked maintenance worker had not only saved 3,000 lives through his extraordinary engineering skills, but had transformed how the entire industry approached emergency preparation and response. His legacy would continue saving lives long after the dramatic events aboard the Poseidon Majesty had faded from headlines. If this incredible story of an underestimated hero rising to save thousands in a maritime disaster captured your imagination, hit that subscribe button to join our community. Have you ever known someone whose true talents were overlooked until a critical moment revealed their exceptional abilities? Share your thoughts in the comments below. We read every single one and would love to hear your stories. Do you think there are more unrecognized experts around us than we realize? Let us know, and don't forget to turn on notifications by clicking the bell icon so you never miss our daily uploads of extraordinary true stories that remind us heroes often hide in plain sight.